Good morning, everybody. Welcome to another session of Psych 3500. We will be continuing now with chapters 2 and 3. Okay. Chapter 2 will be about how to find a good test. We'll be going through that fairly quickly. And then the second one will be on woohoo, exciting stuff, norms. Okay. So without further ado, let me pull up my screen. That, I will pull up my screen and there we go. Let me pull it up even further. Alrighty then. Without further ado, let's do. Okay. So, as a psychologist, you very well, particularly if you're a clinical psychologist, very soon you will be faced with the situation of finding a test. Alrighty. By the time you're practicing psychologist, you would have had your graduate training in testing, so you would be familiar with the test. Well, what about if you're not so familiar with the test? You've heard about a test, but you don't know it super well, or you don't know if a certain test exists for what you want to measure. Yeah. Let's just say, for example, you want to measure someone's degree of acculturation to the United States. Yeah. You're dealing with, let's just say, second generation Mexican immigrant. And one of the issues for them is adjustment, yeah, to the United States. So maybe besides just using your gut, or based just on your experience of having a few Mexican friends, or what you see on television, you don't want an actual number about where this person is at in terms of their maybe their Mexican cultural identity, yeah, or American cultural identity, and maybe both scores, and to see how they fit or don't fit, yeah. Just as a quick example. So let's look at some of the ways, some of the sources of information for tests. Okay, now kind of touching on what we just mentioned about, so these are some of the problems, right? And one of the ways to find out about a good test is to go online, type the test, see who publishes the test, yeah? Because tests are just like books or a number of other products, yeah? They're published. They are published and produced, right? Someone has a copyright on the test, and then they make copies of it, and then they sell it, right? We talked earlier about how it could be quite lucrative creating your own test, okay, which it can be. Find something that needs, find a need, right? Find a demand, just like anything in the marketplace, and then create it, all righty? So you go online, you find out the publisher of a particular test that you're interested in, and they very well will offer what's referred to as an examination kit. Yeah, these are usually for tests that involve that are more involved, yeah, where let's say someone has to, that's just a cognitive test and they have to arrange a puzzle in a certain way, right? They might give you a sample of the puzzle, all righty? Or it's a personality test, and even though it's a multiple choice personality test, they'll give you a kit, meaning a couple sample tests that you can run, and then let you download the software so that you can score it a couple of times. Alrighty, so that's a good way to figure out, to find a test and figure out, hey, is this gonna take care of your particular need, okay? But besides the examination kit, yeah, which can also include, besides the test, the example of the test manual, so you can flip through it and find out some of the psychometric properties, characteristics of the particular test. What are some other ways of figuring out what tests might be available? Okay. Now, online and in a lot of university libraries, right, there are what's referred to as comprehensive lists of tests. Yeah, it's just like lists of any kind of products, all right, cars and so on, computers and whatnot, okay? For tests, there are two main publications. One is Tests in Print, and the other one is literally just called Tests, all righty? Each of these publications, if you find hard copies of them, like, when I was an undergrad, I wanted to take a look at a particular test, and it was actually, I think, on the first floor of the Hamilton Library, and I think it was Tests in Print, and it literally, at the time, it was like 8 huge volumes, at least 8, and each volume was like about 3 to 4 inches. And, so those, it was like binders of, it weren't binders, it's actually text of information about different tests. It was like an encyclopedia. Alrighty. That's why probably most people go online to access information about tests in print and tests. Alrighty. And so when you look at this encyclopedia, just like any kind of encyclopedia, it describes the test, but in particular, it gives information about the research on the test. Okay. Now, another publication is a directory of unpublished mental measures. Okay. Now, you might ask yourself, why do I want something that's unpublished? All right. Well, if you want to go in the initial situation we talked about wanting to make money, right? You create a test, you send it to a publisher, just like a book. If they accept it, right, they publish it, and then you get money for that. All right, very nice. But there are also tests which are created by people that never get published because they never submitted it for publication. They weren't interested in that. Yeah. Let me tell you one story. My brother, who's an MD, first was in a PhD program for clinical psychology, but then decided psychology wasn't really it for him. It was more medicine. But what he had done before he made the switch was he had completed his master's. So he went halfway. And for his master's, what he did was he developed a test. And what it was a test of Japanese cultural identity. And what he had devised was, I think the test included about 60 items, which assess things such as your knowledge about Japanese culture, cultural practices that a person, does or doesn't do, foods, all kinds of stuff. And then it generated a raw score. And what he did, it was actually kind of interesting for his master's study. He had collected a few hundred people at UH Manoa, some who are all Japanese, some who were white, and some who were mixed Japanese. Yeah, either half white, half black, half whatever. They weren't just Japanese, but I think they were at least half Japanese. Yeah, and some other cultural ethnic background. So he had 3 groups, and he gave them all the test, generated scores. And what he wanted to see was whether his test could identify people and their group membership. Yeah, just seeing the score, would it correctly identify the subject's group membership? And lo and behold, it did. Yeah, to a statistically significant degree, which is kind of cool. Good for him. He came up with good test items, which could really kind of sniff out who's who and so on. Yeah, sniff out is kind of a bad way of saying it. But it was very good. It had discriminant validity. Okay, we're not talking about like racial discrimination. That's bad. We're talking about statistical discriminant function. You had that ability to designate what group someone was in. Discriminant function might be in a test for depression. If you want to be able to discern who is suffering from a clinical depression from a just the usual blues or feeling sad. Okay, but my brother Matt never published it. He wasn't interested in doing that. He was just interested in completing his master's. Then he moved on his merry way to medicine. But so he never published it. But because it was a master's thesis, it did make the into the collection of dissertations, which there's a whole collection of master's and PhD dissertations, and so on, which you can look up. Now, the limitation of those studies are that they never were published in a peer-reviewed academic journal. Okay, so in other words, there wasn't a group of people knowledgeable in the field who looked at what the person who submits their article to the journal did to determine whether it was good science or not. Now, in the collection of theses, so the master's or PhD level students who did the research, it was evaluated by a committee, right? Their master's or doctoral committee, which is good, right? Kind of cool. You got PhDs, academics evaluating the quality of the research. That said, it still isn't the same as a academic peer publication where you have designated experts in the field evaluating the studies. Okay, and the reason why you might want to go to the unpublished test is because there are tens and thousands of tests which are never published, which are studied, and which might be helpful for you. right? Because you may not find a published study for the particular thing you're interested in, but it may be an unpublished study, okay? And then we have ETSs, right? Educational Testing, what is that? Society, I think. ETS, right? The people who brought you the SAT and GRE, evil empire, okay? ETS. They have their publication of published and unpublished tests. Also, what you can find to help you find or locate a good test are systematic reviews such as the Mental Measurements Yearbook, which is particularly designed to evaluate the quality of the test based on research. You have empirical support for a test, like the IQ test has great support, MMPI, Milan Clinical Multi-Axial Inventory, another personality measure used as much, not as much, but almost as very popular, almost as popular as MMPI. The Myers-Briggs, in terms of research support, you know, there's some, but for the most part, you don't use it as a psychologist. That's why it's not cited or talked about at any length in our textbook. Okay, the Myers-Briggs. But the flip side of the Myers-Briggs, very popular. You see it all over the place. Yeah, which kind of reminds us that old lesson about things that are used by people which aren't empirically supported, that don't have a much scientific basis, but are really popular. Especially, it can happen in any field. It can happen in medicine, but certainly it happens in psychology, right? Because people like it, they dig it, it appeals to them. But even though something is appealing, doesn't mean it's valid. All right, like the Myers-Briggs. Okay. There are other electronic listings of tests besides the ones we've mentioned. So maybe my list for listing of forensic tests, tests used by teachers, stuff like that. There are also a lot of books on some of the major tests. So some of the big ones like the IQ, the MMPI. Very often there are tons of books written about these really good tests. And what's good about what the books do, besides maybe talk about the research or how to use the test, how to interpret the test, which is all really good stuff, right? They very often come up with to describe certain ways of looking at the test or using the test. Sometimes ways in which it isn't designated in the manual, but it's still legitimate because it's a legitimate use of the test. Okay. Academic journals. There are other public, if you want, just go to the publishers and the publishers will give you their catalogs. But, probably, honestly, I mean, it's hard to, no one's ever going to do a study on this because it's hard to get the data. But anecdotally, probably the way most people find out what tests to use, they ask other people in the field. Okay. So if you're a high school counselor, you probably turn to, Johnny or Mary, who's been a high school counselor for 20 years, presuming they're not on drugs and stuff, but, they're legit, they're good counselors and they're not on drugs. And you ask them, hey, what do you use? What's a good test? All that kind of good stuff. That's probably the most common way people figure out, what test to use. Okay, and this is an example from the Mental Measurements Yearbook, an online example of a query that I did for test on probation that could be used by probation officers on parolees. Yeah, so you can see very quickly, here's the purpose of the test is designed for an adult population and parole risk, right? Now on parole, are they at risk for breaking parole? It tells you that there are 8 different scales, right? It mentions alcohol, drug use, how aggressive they are, really important if they're out in the public, right? If they're antisocial, how it's administered, typically in a group, right? So you might give it to all your, if you're a probation officer, like I have a cousin who's a probation officer, and he works with adolescents, loves his work. You can administer it to the group in about 30 minutes and so on. Yeah, so very handy dandy. So with that, that's all I have to say about chapter 2, yeah? Woohoo! Very brief. And with that, let me get out of here and try to locate. Okay, there we go. And we will continue in a moment. Our next chapter. All righty, here we go. Here we go. All righty. Chapter 3 on test norms. Okay. Doesn't sound super exciting, but it's actually very cool stuff, important stuff you need to know as a scientist, as a psychologist. Okay, what are test norms? What's meant by that? Yeah, we'll have a discussion on raw scores. Then we'll have a discussion on what norms are, the different types of norms, and then finally a discussion about different normative groups. Yeah, because that's besides understanding what norms are, one of the things that's really important is to understand how the what the normative group is or what's the comparison group. Yeah, you're taking your patients, your clients, your whatever students score, and you're comparing it against these other scores. Well, who generated those scores? I mean, that's important for you to know. Okay. The obvious example is if you're testing a 17-year-old and then you're comparing their scores and the normative samples, includes only adults. I mean, 17's right, kind of on the border. How do you think about that? All righty. So let's first talk about raw scores. Okay. Now, what the raw score is the number you get, right? The initial number, score, result, outcome from your test. Okay. What's a simple example? Let's just say you give a quiz with 20 items, and each item can be right or wrong. So it's a point or no point, 1, 0. And the more points you have, the more correct you have, right? Or the more stuff you know, the more stuff you got correct. All righty. So if you got a score 15 out of 20, that's your raw score. All right. Now, there are a number of things you can do with a raw score, right? So a raw score isn't just a number in itself, and that's the end of the story. There are a number of things, even before we get to norms, that we can do to raw scores to kind of understand them a little differently or view them a little differently, even before we get into norms. Okay. Now, one thing we can do like with the example, the first example of a way you can manipulate a raw score is the correction for guessing. Okay, what is that? All righty, well, the correction for guessing is, so you can kind of guess, is something you can do to a test in order to account for, take out the function of guessing, right? For example, in that 20 item test, you want to know what the student knows. You don't want to figure out how they're doing just because they had some lucky guesses. Okay. So one thing you can do, like with a multiple choice test, is apply the correction for guessing. Now here we have the formula for the correction of for guessing, right? And what this represents here, RC, is the correct, what you're gunning for. You want the correct raw score, right? Because I'll tell you how much they really know. This is the original score, which you may not be as interested in, minus the number of wrong answers they had, divided by the number of options, like on a multiple choice test, that'd be 4, minus 1, or here, right, we'd be divided by 3. So let's look at a specific example. Okay, so Johnny here got a score of 40. He got 40 correct and 10 wrong on a 50 item multiple choice test. Okay, let's presume 4 options, right? A, B, C, D. Okay. Using the correction for guessing formula, right? Johnny got a 40. You want to subtract how much he got W wrong, which was 10, divided by the number of options, K, 4 options, A, B, C, D, sorry. 4 minus 1, 3. So the number wrong divided by 3 is 3.33, right? And then you divide the score minus 3.33, and the correction for guessing is 36.67. Okay. So what this is doing, it's removing any impact of lucky guesses, all righty? And just giving you a modified, a revised score, which is probably, which may be a better estimate of what the student actually knows. Not a 40, right? Because we took out all the guessing crap and we're left with what Johnny really knows. All righty. Now, very easy way to correct for raw score. I don't know of any university professor who uses it. And why? Well, in part, probably because hardly anyone knows about it. The other thing, and students are probably thinking, thank God no one knows about this, because it would probably be very, very unpopular with students if they knew that there was a correction for guessing applied to their multiple choice performance. Second thing is theta, yeah? Now, what is theta? Well, theta arises from item response theory, and theta is a number, right? It could be 1, it could be 50, it could be negative 2.5. It is a value, all righty, that is derived based on item response theory, and that value, right, that what you can do with that, what that value represents is some characteristic of the test. Yeah. So if it's an easy test, right, theta might be a value which increases the scores. Yeah. Um, uh, I'm sorry, if it's it might decrease it, right? It might be a negative value, you decrease it if it's an easy test. And if it's a hard test, right, it may be a positive value, which increases whatever you got because, right, it was a hard test. So you actually, to show that you actually perform better, it may be a positive value, something like that. Yeah. Bottom line is that theta is a value that takes into account the characteristics of the items. Okay, it's not just looking at the raw score, but looking at the types of items. Are they easy items, difficult items? Sometimes it can take into account the sequence, like were they easy before but difficult later, or vice versa, and so on. Yeah, so it's very typically used if the person administering the test is administering different types of two versions of a test, for example, and one may be easier than the other, very simply. So you might want to use theta to correct for the fact that one test is easier than the other. Or maybe the subjects are given the same test. Yeah. So all the subjects get the same test with all the same items, but each one shows a different pattern. Yeah. Now, some people, imagine one student, super bright, knows the material, but she rips through the first bunch of items because they're easy, but because she rips through them, right, she makes a lot of silly mistakes, but she gets the tough ones. Okay. Whereas another student, yeah, right, isn't as brilliant as Susie is, but she's average student, average mental ability, but she's careful, right? So she does a lot with what she got, with what she has, and so she's careful. So she gets all the easy items correctly, and then when it gets to the difficult items, some she gets correct, some she doesn't, right? So what you want, this is where theta can come into play. It takes into account different possible examinee responses, and then would apply the theta, right, to the raw scores to take into account, all right, so it's not just that the first student, got a lower score than she should have. The theta will kind of revise that, right, kind of be applied to the raw score, and then the value of theta will increase the score. So it's a better reflection of what the first student did based on her pattern of response. If it's clear that she just goofed up, made some silly mistakes. Okay? So that's the idea. And finally, ipsative scores, a third category of ways we can manipulate raw scores, refers to a score on a test which goes to two or more different, you can say, indexes. Okay, what do you mean by that, Tsushima? Okay, now when you think of a test like the math test, right, it has 20 items. Every item you get correct, it suggests that you know your math better. Okay, so your score is that raw score, 15 out of 20, right, goes to one thing: how well do you know math? Right. Ipsative scores refers to tests where a raw score actually suggests different things. Okay, two or more things. So for example, right, we have the Minnesota Multiphasic Personality Inventory, and it generates raw scores, and it has about, what is it? I think 300 or so true or false items. And if you say true or false, it goes to different things. So for example, there's an item that asks the subject, I try to always obey rules, true or false. Okay. Now, if you indicate true, right, that may lower the antisocial personality score. Okay, because clearly, if you try to follow rules, right, you're not antisocial, right? You're pro-social. You're concerned about others, right? That said, that one item may also go to depression. You know, someone who always tries to obey rules might stress themselves out, might get anxious about rules, might get emotionally upset. So that may be an item, if you endorse true, increases, right, your depression score. So decreases one and increases another. That's the idea of an ipsative score. One response goes to different indexes, all right? It could be even more, depending on the particular item, yeah, and what it's related to. So one item can relate to two constructs in two different ways, in two different directions. Alrighty, so those are the three, right? Correction for guessing, theta, and ipsative scores. Alrighty, let's move on. And actually, before moving on, let me just get out of here. And let's continue. Okay, sorry about that. All right, folks, so continuing. Let's move on right here. We will have, when we meet in Zoom, we're going to have a review of variance and standard deviation, so we won't go through that now, but a little heads up. Okay, we'll be going through some of this stuff, and actually, let me just pause this for a moment. Just down here. And boom, let's continue. Norms. Alrighty, so let's get to what norms are. Okay, when you hear about norms, what they refer to is the standardization of tests. Okay, now when we're talking about a set test being standardized, we're usually saying a few different things about the test. Okay, it certainly refers to how the test is administered. Yeah, and when it's standardized, there's a uniform procedure for giving the test. Yeah, you may recall the example mentioned in the previous YouTube video about the SATs, right? There's a very set procedure you follow, and the reason why you do that is that it allows for test interpretation. Okay. It also means stratification of different variables or isolating quantitatively different variables like age, gender, education, occupation, and so on. Yeah. That for different tests, we want representation of different certain demographics. Yeah. So we can be sure that the test is generalizable. Alrighty. Or when psychologists give or anyone gives a test, right, the examiner, and they're trying to interpret the examinee's score, they'll know the examinee's characteristics, and they want to see if it fits the characteristics of the normative sample. Okay, now, as a general rule, does there have to be a complete perfect fit between examinee and the stratified variables for the standardized test? No, right? Very often you won't. All right, we'll get into an example maybe a little later. Johnny might be 17, but the test was normed on adults. Does that mean you absolutely can't give the test to Johnny? Probably not, if there's no adolescent child version, right? Does that mean you can't give it to Johnny? No, it doesn't mean you can't give it to Johnny, but it's a big qualifier, right? It depends on the adults. If the adults are like 18 to 50, yeah, probably. If the adults are 35 to 65, maybe not. It all depends. Yeah. We'll probably get to another example of that later in the program. Okay. But standardized test also refers to, yes, sometimes, but very typically, that you have norms for the test. Yeah, that in other words, the test has been given to some subjects. You got their scores, so you have this data of all these scores from other subjects, and you can compare your examinee score, your patient, your student, whatever, to that group. okay? And that's the strength of a test. And an important maxim to keep in mind as a psychologist is that any test without norms, comparison group, is only as good as the examiner. And there are a number of tests out there that don't have norms. So you got to keep that in mind. If you run into such a test, it's only as good as you are, And the whole point, actually, of giving a test is you kind of want this objective third party, right? That's what the test you can think of, right? Is that this objective, like, third party that's going to evaluate your person that you're interested in, your patient, kind, who have you, based on the questions that they ask or the tasks that your examinee has to do for this person, not a real person, but test, right? And then that test will give you a score. That's kind of the idea. That's kind of the point, okay? Otherwise, you don't need a test, right? If it's only as good as you can just ask a bunch of questions and you're not giving a test at that point. Okay. So the normed, what is meant by a normed score? A normed score is when the raw score is compared to that normative sample. Okay. Now, in order to make that interpretation, what's important is to understand statistical concepts like the mean, standard deviation. We'll get into percentile rank and Z-score. Now, there are different categories of norms. There are like I just mentioned, the percentile rank. There's the standard scores, right? The old Z-score, what that means, as well as developmental norms, which we may get into. Okay, so what is a percentile rank? Yeah, well, you guys have probably been exposed to percentile ranks in the past in your own educational experience, right? Percentile rank, when you hear you're at the 75th percentile rank, hey, that sounds like good news, right? Sounds familiar. Well, that means, right, that the percent that it reflects the percentage of cases who performed as well or below you, right? So you're woohoo, right on top. You're on the top quartile, right? Because 75% of everyone else who took the test performed how you performed and lower, right? So if you're I'm king, 75th percent. Now, if you hear you got the 35%, you ranked at the 35th percentile, you're not as excited, right? Because that's telling you 65% performed better than you. Alrighty. So percentile rank, again, is percentage of cases at or below how you performed. Okay. Now, a percentile, right, is the point on the scale at and below which a specified percentage of cases fall. Alrighty. So let's just say the test there are 300 items, right? And to be at the 75th percentile rank, you needed to get to be at the 75th percentile rank, right? Woohoo! You're all excited, right? You needed to get 250 items correct. Okay, that's the percentile, 250. That's the number of items. Okay, the point on a scale that led to the percentile rank. There's a little subtle thing, and to be quite frank, you probably find examples of how these terms are used interchangeably. But from a technical standpoint, these are the differences. Okay. Now, one of the drawbacks of the percentile rank, you're at the 75th percentile. Yeah, it doesn't mean how much you got correct on the test. It just means where you stand in a group. Okay. So it depends on what the instructor is interested in. Are they interested in how many questions you got correct? Or are they interested in your standing in the group? Yeah, depends. It's different information, right? The other thing is that there's a probability of inequality of units at different points of the scale. Yeah. What does that mean? Yeah. Well, just because you're at the 75th percentile rank, right? It's not like the scores are distributed evenly, like in a rectangle, right? So 75% here, 50% here, 45% there, right? Maybe 75 is here, 50s, 60 is here, 50 is here, 40. So it could be distributed differently, right? So that can make interpretation a little tricky. Here's an example from the SATs. I forget what year, but it was in the 2000s, right? 2005 or something. Yeah. So you can see, we can have a discussion about percentile rank here. Now, let's just say you got a score 640 on verbal. Okay. So the score, which is the column to the left, right, is 640. And you can see that yep, here's my cursor right here, 640. And that's a percentile rank of 87. All righty. So if you got the percentile 640, right, the score, you got the percentile rank of 87%. Quite exciting for you. Okay. What's a flat 500, just for example here? And closest we have, oh, here we go, 500. So 500 on the SAT verbal, you have the 46. So you're average, right? But a little skosh right below 50%, right? What if you got a 500 in math and you're about 43? Okay. Now, if you got a bunch of percent of raw scores, right? You have 30 students, they all took a quiz, and you want to find out the percentile rank. How do you find your class's percentile rank? Okay. Well, you take those 30 scores and you range them from lowest to highest. Yeah? So whoever got the lowest on the 20-point quiz, whoever got the highest. Okay. Then you determine the number of participants who scored at and below your score of interest. So after you've done a frequency, right? You can say three people got a 5, 10 people got a 10, 3 people got a 15, 2 people got a 19, something like that. Okay? You arrange the scores from lowest to highest, then you count the number of people who scored at and below the score of interest. So let's just say you're interested in the percentile rank for a score of 10, right? So you look at 10 and count the number of people who got 10 and all those people below 10, okay? Then you take that number, you divide it by the total number, right? So in this case, let's say 87 students, right, took the quiz, and I'm sorry, 100 students, and 87 at the end got at or below your score of interest. Okay, let's say the score was 10, right? So 87 people out of the 100 got a score of 10. Then you take 87 divided by 100, which is 0.87, and they're at the 87th percentile rank. Okay, quite exciting. All those folks did quite well. Okay, now, another way, besides that very simple way of just listing out the raw scores, is by using the z-score, okay? Now, the z-score, the way you do it is you first take this person's score, right? 10 minus whatever the mean is for that particular sample, divided by its standard deviation, okay? That'll give you a z-score. Okay? And you take the z-score and you look for the percentile rank on a conversion table. Alrighty. So what's an example of a conversion table? Well, here's one. I don't know if it's still page 78. I think we got a new edition of your textbook, so it may not be page 78. But somewhere in your textbook, there's this table, and you take, let's just say Johnny got a z-score of 0.5, right? So here are the z-scores. You look at 1.5, it's right here. So Johnny, right, his percentile equivalent is right around here. Okay, that's what 1.5, right? And you can do that because when you've converted Johnny's score to a z-score, and you found that Johnny had a z-score of 1.5, right? That's standardized. So you can compare it to this kind of theoretical distribution of scores, right? With all this handy-dandy information. That's, again, as we spoke about in the previous discussion, the value of a z-score, right? You can take that value and then apply it to the theoretical probability distribution, okay? All righty. So if we take a look at the percentile rank, let's just say this is a student's scores, and these are the means on the SAT, math and verbal, and the standard deviation, right? So if you want to find a z-score for this, it's simply student score minus the mean divided by the standard deviation. All right, standardized variance, standard deviation. And here we got positive 1.25. So this student did better than average. All righty, 1.25. And his verbal, right, he got a 450. Here's the mean and standard deviation. Take the score, subtract the mean, divided by the standard deviation. It's negative 0.50. Alrighty. Now, you know he did lower than the mean, but not below 1 standard deviation, right? This is above 1 standard deviation unit. Let's go back here, right? These are the 3 standard deviation units. Yeah? We know that in the first, right, this, and you can think of 1 standard deviation above and below the mean as average. So this person did, what you could say descriptively as above average, 1.25. But in the math, they got a 0.5, negative 0.5, negative below the mean. So they're doing average, but it's below average, right? And that's kind of interesting information. Why is their verbal above average but their math average, but if anything on the lower end? Okay. Oh, I'm sorry, I kind of reversed that. The math was the superior and the verbal was less so. Okay, so this person's more of a math person. All righty. As we spoke about before, standard scores are taking the raw score and converting them, right, into the z-score, because you take the score minus the mean over the standard deviation, and that standardizes the score. You can, besides doing it that way, which is the general, usual, typical method of doing it, another way is by standardizing the score using the characteristics of a particular test, okay? So you take the raw scores, you convert it, and then you take that z-score and then you apply a new standard deviation, let's just say to a particular test, right? New version of a test plus the test's mean, right? For that research sample, the standard deviation and mean. So it's a way of converting the z-score. Again, you can standardize it once and then you convert it again by using the characteristics of a given test. But this is for your eyeballs here. This is from the IQ test, there are a number of IQ tests, but this is the most common, the WAIS. And what I have listed here, it comes from, this is the second version. It's in its 4th version, but in the second version of the IQ test, and it's broken down into different categories here of where you perform, okay, on the bell-shaped curve, and what that means, the score, the IQ score, where it is on the bell-shaped curve, okay, the percentile rank from the actual sample. Well, I'm sorry, it's not the percentile rank, but the percentage of people who perform, right? Most people perform here, which is average, low average, high average, right? You can expect this, right? 50%, and then 17 above, 17 below, but then fewer super high, fewer super low. And the classification, the term used for someone who has an IQ 130 above, 120, 129, and so on. Yeah, just thought, but keep in mind this is from the second version of the test. It's currently in its 4th version. Soon, coming out at a bookstore near you in its 5th version. Red Bull. All righty. So what else does the standard score system do? The other thing that it does is it takes the scores, yeah? So when you get the raw scores and you standardize it, okay? A lot of the time what a standard score, or what standard score systems, not just the z-score, but standard score systems do, is that they do what's referred to as a linear transformation. Okay, in other words, where things stand in one bell-shaped curve, it kind of converts it similarly. Okay, so it's more or less the same. It just kind of changes, modifies the distribution or the bell-shaped curve a little differently. But some will do what's referred to as a non-linear transformation. This is what we have here. Okay, where these are the scores, but because it's so skewed, the standard score system has to kind of rejigger or reshape it so it looks more, because this is hard to interpret. This is trickier. Yeah. But it makes it more like the bell-shaped curve so that you can interpret. It kind of forces it. It takes these scores and kind of scrunches them up into a bell-shaped curve. Alrighty, which is of course always something to keep in mind when making interpretation, is that there was an artificial conversion of the what do you call? Not to be confused with stupid conversion therapy, but converting a distribution that's skewed into something that's normally distributed. Alrighty then. Other versions of standardized scores, besides Z-scores, there are things called T-scores. The SATs, just so that you know, some of their normative data include the fact that for this mean scores like math and verbal, the mean performance is 500. I think the range is 2 to 800. Yeah, yeah, and a standard deviation of 100. And the IQ test has a mean of 100 with a standard deviation of 15 or 16. 15 typically for a test called the Wechsler, and I believe 16 for the IQ test called the Stanford. Now, what are the strengths and weaknesses of standard scores? Okay, strength of them is that they provide a way for us to interpret test performance, as we just saw a moment ago. Okay, it also allows us to compare scores from different tests. Alrighty, or in the previous example, yeah, a different subtest within the same test. So you had a math score and a verbal score. The math score was 650, and I think the verbal score was 480, something like that. But it's hard to say, okay, one's higher, one's lower, but what does that mean? But until we converted it to a Z-score, then we didn't know that the person was performing above average on math, and then average, but low average on verbal. Okay. Now, the author mentions that one of the drawbacks of standardized scores is that you need to know the meanest standard deviation for the system. But you know, as an aside, I don't think this is the worst weakness in the world. Okay, so comparing raw scores from different tests. Here's an example. Now, as many of you are familiar, very commonly in college admissions, two very common tests besides include the SAT, and the other one's the ACT. Excuse me. And I think it's the academic curriculum test. Sorry, I don't exactly remember what the acronym stands for. But the SAT is kind of thought of more as a test of ability, and the ACT as being more of a test of achievement. Yeah, reflecting more your experience, but not as much your capacity or mental muscle. So here we have a test. We have a person who got a 620 on the SAT and a 27 on the ACT. Okay? But you look at that and you're kind of asking yourself, well, what does that mean? Okay. Well, what you can do, it's kind of hard to tell what that means until you apply the mean and standard deviation of each test to produce a Z-score. Okay, and if you produce a Z-score, then you can compare the two tests. So if we do that with the ACT, right, what's a 27? Well, a score of 27 minus a mean of 25 divided by a standard deviation of 2.5 gives you a 0.8, right? So you know from that Z-score, it's a positive value, right? So it's going to be average or above, and that it's 0.8. It's not above one standard deviation, but it's getting there, right? So you can describe this person as high average on the ACT. If you looked at their SAT, right, they got a 620. So you take their score minus the mean divided by the standard deviation, you get a Z-score of 1.2. Okay, and that 1.2, right, is positive, and it's above one standard deviation. It's above average. Right? So the way you interpret this, now you got really something kind of important here, yeah? And a different kind of academic functioning information than the previous math verbal example we looked at. Here we can see that on a test on the SAT, which is more of a test of mental ability, yeah, this person performed above average, whereas on a test of experience achievement, yeah, it's it's average, high average. Yeah? So you might ask yourself, it's kind of interesting. So maybe this person has more of a potential to do well, as opposed to actually doing well or learning from their experience. Okay, we're going to skip developmental norms. I think those are a little more straightforward. I think this is kind of interesting thing for us to kind of pause on for a moment. Yeah, here's an example of the California vocabulary scale. Okay, that it's broken down by grade level, and here we have on the right column the average raw score. and given an increasing higher average raw score, it suggests a different grade level, right? So if you're performing at an average of 35, you're performing at the third grade level. Now, here's a question I'd like to pose to you. Right? You're a school psychologist or a counselor at a grade school, and a student, right, second grader, scores a 37, a second grader. Okay. Mom hears about the score. She comes to your office the next day, super excited and elated because her little Jenny got a 37 and she's only a second grader. Wow, does she have a superstar? Does she have a brainiac on her hands? Should she fast forward her to the third grade or maybe even the fourth grade if she got an average score, right, of 37? Because isn't she performing as well as a fourth grader? How would you answer Jenny's mother? Yeah, so you might want to pause and think about that. If you're thinking like someone who understands norms, you'll say, well, it's probably not fair to say she's performing as well as a fourth grader just based on this test. Okay. What this test only tells us is that, right, her vocabulary, her word knowledge is as good as a fourth grader. Right? Now, as an aside, vocabulary is related to IQ, and it's related to a lot of other cognitive functions like reading comprehension and so on. Yeah. And I'm sorry, I called this a reading test before, but it's a vocabulary test. Okay. So you can say Ginny's word knowledge is as good as a fourth grader. Yeah, which is kind of, you can tell them, Mom, that's cool, that's great, you know, and you can speculate as to what they might be due to. Maybe Jenny reads a lot or she's read to a lot, all that kind of good stuff. But that's all it tells you. It doesn't tell you if she's performing like a fourth grader. Alrighty, you need to administer a number of other tests before you can say something of that sort. Yeah, and certainly there are other implications about having someone skip a grade or two, certainly two. Okay, moving right along. Oh, just a little quote I like. Notice that the stiffest tree is most easily cracked, while the bamboo or willow survives by bending with the wind. I like that. It's a Bruce Lee quote. And the less effort, the faster and more powerful you will be. I love that quote too, a whole bunch. And here's a picture of Master Bruce Lee on the left, socking a guy in the chest, giving what's referred to as the 1-inch punch. Now, the 1-inch punch, for those of you who aren't familiar with Bruce Lee, nor the 1-inch punch, is the something that Mr. Lee used to demonstrate in front of masses of people, where he would get a volunteer, the person we'll refer to just for the moment as sucker, to the right, and then they would measure literally 1 inch between the person's chest and Bruce Lee's fist, and Bruce Lee would just within an inch go boom, and this picture doesn't really show it, but if you see a video, you see the person just really fly back in the chair by about 10 or 15 feet. Alrighty, and I think the point of this demonstration of physicality is focus. Yeah, attentional focus, physical focus. So a little lesson from Bruce Lee. There was a little Bruce Lee moment, by the way. This is just referring to a previous class. Oh, that's referring to something we'll do later, but let me get out of this. In the meantime, we'll get to stuff like that a little later, probably in our Zoom meeting. Alrighty, so what are the different types of norm groups? Okay, the major types include, ta-da, what we're going to be looking at right now. You have a national group, and we get this with the SATs and the GREs, yeah? So test is administered to everyone in the country. Well, not everybody, but those applying for college. And even then, right, not everybody applying to college. Well, probably almost everybody applying to college that year, right? It's hard to, I guess, and like some people applying to college and they don't take the SATs, and they go to universities that don't administer the SAT. Okay, there are, in some situations we do have international tests, norms generated with international samples. So we'll have, let's say, grade school students from Germany, Korea, Iran taking a math test. Yeah, we usually do that every year, collect that data. Yeah. Um, and by the way, as you're probably well familiar, when it comes to the United States on math and science, we don't do so hot. I mean, we don't do the worst, but our national ranking, we're in the 20s, For the richest country in the world, we're like 25, 23. You know who tends to be number one on math? Well, very typically, the top three is almost always some combination of China, South Korea, and Japan. But very often, who's numero uno among those top five? Iran. Interesting enough, Iran is almost always number one. Number one and two, they always flip flop with one of those other Asian countries on math, yeah, and science. Something to contemplate on the importance of test data and how we should respond to that kind of stuff. Many times group normative samples are convenience groups, yeah, whoever people can get for their test, to take the test and develop it, right? Because it's not an easy thing to get people to take a test. It is easy when you're Evil Empire, ETS, and you tell students, hey, guess what? This is what you got to take. Pay us a fee. And which is, as you know, with the SATs and GREs, right? Yeah, big billion-dollar industry. So another thing to think about. Alrighty, let's look at some national norms. With the Wexler, the IQ test, and the second version, it was normed on a sample. Now, they did it very scientifically and in very controlled circumstances. They gave it to 2,000 people. And part of the reason why it was very controlled is because the Wexler Adult Intelligence Scale, or the WAIS, is very difficult to administer. It's not like you flop a paper test in front of someone and you say, hey, go at it. It's very complex. We'll get into that in a later chapter. You'll see how involved it is. And it takes at least 1.5 to 2 hours, and you have to have the examiner there from beginning to end. Okay, the sample included 2,000 people, and they got fair representation across race, sex, age, and so on, based on census data. MMPI as well, personality inventory. A little different though. They have based the second version on about 2,600 subjects from 7 states, and these are the 7 states. Interesting, right? So 40 states, 43 states not represented. Now, if you look at these 7 states, right, we got a good sampling from different regions, right? But I don't have to tell you, right? Not all states are created equally. Many are kind of similar, but if you could say the Northeast versus the Midwest versus the South, I mean, there are some commonalities, but I'm sure many of those states would be offended if you said they were exactly the same, right? Which arguably they probably aren't. And then what do you do about Alaska and Hawaii, right? They're not represented here. Now, does that mean you can't give the MMPI to Alaskans or Hawaiians? Right? I'm not saying native Hawaiians, I mean citizens of Hawaii. Of course you can, right? But you gotta just keep in mind, right? Be educated, know who the normative sample is, okay? So it's totally legit to give an Alaskan or person in Hawaii the MMPI test, okay? Give them a score, it becomes part of their permanent record, whatever that is. But yeah, if you're called into court, you could be cross-examined on this, and maybe cross-examiner, right, the attorney for the other side will say, but doctor, isn't it true that these norms were based on people from these states? You'd have to say yes, but you'd have to also say that doesn't preclude you from using the score to, and apply the score in this case, right, to the normative sample. Right? Some of the arguments for it is because you got a wide distribution of different states, even though it's not Hawaii per se, right? You got a nice, it's also really large sample size, right? So you're probably going to get all different types of wider range in age, ethnicity, and so right there, 20% non-whites, which almost 20% non-whites, which is pretty good if you want to apply it to a Hawaii subject, stuff like that. Okay, and these are other groups. I don't think it's necessary for us to get into. Now, another way of interpreting someone's performance, yeah, is what's referred to as criterion reference interpretation. Now, criterion reference interpretation is different from normative interpretation, right? We've already talked about normative interpretation. I won't have to revisit that. Criterion reference interpretation is different, yeah? It refers to the idea of interpreting someone's performance on a test, yeah, or different tasks, yeah, but certainly a test, with a predetermined criteria or criterion. Yeah. Now, what's a classic example? Classic example would be education. Almost all educators use criterion reference interpretation. Yeah. What's an example? You know, you might be in a class, and the instructor said there'll be 4 tests, and in the 4 tests, you can earn up to a total of 100 points. Excuse me, 25 points on each test. And if you get a 90, you get an A, you get an 80, you get a B, and so on, right? So you met a criterion, right? You got 90% of the points, or 90 points, or 80% or 80 points, right? It doesn't have to be 80 or 90 points, but the bottom line is that there's some criterion preset to determine how to interpret that performance, yeah? So for the instructor, the sheer here saying, hey, you get 90 points out of 100 at the end of the term, or 900 out of 1,000 for many of my classes, right? Something like that. You hit an A. You get an A. You get a 90%. Okay. Now, are there advantages and disadvantages to this versus using normative interpretation? Yeah, you betcha. You know, maybe we'll have a little discussion of this in our Zoom section. But this is something to think about. What are the advantages and disadvantages of norm reference interpretation versus criterion reference interpretation? Okay. What if your instructor did normative interpretation in terms of criterion reference interpretation? What would that mean? Well, first of all, what that will mean, let's kind of flip up a bit here. Oops, I went the wrong way. Sorry about that. Oop, I sure have to go up a bit. What that would mean is that 60% of the class would get a B, a C, yeah? 14% would get a D, 14% would get a B, and only 2% would get an A, and only 2% would get an F, okay? So good news and bad news. Hardly anyone will get an F or a D. Most will get C's, but I guess the bad news is much fewer B's and A's, okay? The idea being that the class's scores would be distributed normally, and then your grade based on where you fell on the normative bell-shaped curve, okay? So that's something to think about. What are the pros and cons of that approach, yeah? You know, I remember when I was in law school, some of my law school professors, they went by norm-based, yeah? So the vast majority of us got C's and B's, but very few of us got A's. Now, one thing to think about is what is more like real life out in the real world? Is our world criterion reference or normative reference? Some things to think about. Now, what's the usefulness of a standardization group? Well, its usefulness is going to be based on the stability of scores. You have that same group where to take the test again, with their scores distributed similarly. And also, as you kind of could infer from our discussion, to what extent the group is representative of some well-defined population. Yeah, so that's really important, some well-defined population. Is it college students? Is it depressed individuals? So just like a good study, a good test constructor has to define the population of interest. Now, the stability of scores will depend on the size of the normative group. The more people you have, generally the better, right? If your normative group was based on 15 people, right, you can have a lot of variation, right? It's not like that old blue marble, red marble metaphor you guys might remember from Psych 1000, right? If you have, well, let's just use 10 blue marbles and five blue marbles, 5 red marbles, right? And if you threw them down, right, they're going to gather or distribute very differently each time because it's only 5 blue and 5 red, right? They may be all just by chance, right? But if you have like 200 blue marbles, 200 red marbles, and you threw them down, the distribution is going to look fairly similar. They'll kind of bunch up always fairly similarly, right? It'll always look like a bunch of blue and red as opposed to, bunches or groupings of red or blue if you just had 5 blue and 5 red. Now, sample's representativeness, yeah, will be a function of how to the extent to which the test constructor or the person collecting the normative data can utilize sampling theory from research. Okay? Now we know a simple random sampling from the population is the most ideal, but that's rarely used because it's just not practical. Yeah, it's very tough if you come up with an IQ test and suddenly go, I'm going to simply randomly sample from the downtown Honolulu district examinees who are going to form the normative sample. I mean, you'll be lucky if you get anybody just by going up to them and saying, hey, hi, want to be examinee in my normative IQ test sample? They'll tell you to, what, downtown Honolulu. All righty. And usually what test constructors are kind of limited to or will be stratified cluster sampling. Okay, so they'll find certain strata like men and women, yeah, or let's say racial groups, right? White, Black, Asian, Latino, and so on. And when they go to a college sample and hey, who wants to volunteer, or they do an online thing, they try to get a certain number of men and women, and then fill in slots of Black, White, Asian, Latino subjects too, right? So they don't want their test. If it's let's say you have a sample of 100, you don't want to have 90 Asians and then 2 Blacks, 2 Whites, 2 Latinos, and then 4 other people, right? Because you want your test to apply to a lot of. You're not making an Asian test. You're making a test that can apply to a bunch of people. So what you want to do probably in the United States, Asians make up 4% of the population. You probably want to keep that number down to 4 out of 100, yeah. And so on. Same with the whites and blacks. If blacks make up 14, 17% of the US population, then 14 to 17 black subjects, around there, right? Something like that. And with that, that's all I have to say about chapter 3. Okay. With that, we went through a lot of stuff. We went to chapter 2 with how to pick a test, chapter 3 with norms. When we meet in Zoom, we'll do a number of exercises related to finding the variance and standard deviation, probably some z-score stuff. Yeah, with that, otherwise looking forward. Let me get out of this. Okay, with that, looking forward to seeing you guys on Zoom and going through some of those exercises together. And with that, that ends our discussion on chapters 2 and 3. And see you later. Bye-bye.